Hey everyone, welcome back to BugNoJutsu. In today's video, we're going to solve another interesting problem from LeetCode, find the minimum area to cover all ones. This problem is a great exercise because at first, it might look like you need to use dynamic programming or some advanced logic. But actually, there's a much simpler and elegant way to solve it by carefully observing the grid. Let's break it down step by step, understand the problem deeply, go through an example, and then solve it together in the cleanest possible way. We're given a binary grid, which means each cell in the grid contains either a 0 or a 1. Our goal is to find a rectangle, aligned with the horizontal and vertical axes, that completely covers all the ones in the grid. Once we have that rectangle, we need to return its area. The rectangle should be the smallest possible rectangle that still contains every single one. In other words, we want the tightest bounding box that encloses all the ones. This means we can't leave any one outside, and at the same time, we shouldn't include unnecessary extra rows or columns that don't contribute to covering ones. Let's take the example given in the problem. Here, we can see the positions of the ones. One is at 0, 1, one is at 1, 0, and another at 1, 2. To cover all of these, we look at the boundaries. The topmost row with a 1 is row 0. The bottommost row with a 1 is row 1. The leftmost column with a 1 is column 0. The rightmost column with a 1 is column 2. So the rectangle that covers all the ones extends from row 0 to row 1 and from column 0 to column 2. That gives us a height of 2 and a width of 3. Multiplying them, we get an area of 6. And that's exactly the answer for this example. Now let's talk about how we solve this efficiently. Instead of overthinking with extra data structures, we keep it very straightforward. As we scan the grid cell by cell, we continuously update 4 boundaries: top, bottom, left, and right. Whenever we see a 1, we check if its row is above our current top, and if so, we update the top boundary. We also check if it's lower than our current bottom, and if so, we update the bottom boundary. Similarly, for columns, if it's more to the left, we update the left boundary, and if it's more to the right, we update the right boundary. By the time we finish scanning the entire grid, these 4 boundaries give us the exact rectangle that contains all the ones. Then the calculation is simple. The height is bottom minus top plus 1, the width is right minus left plus 1, and multiplying them gives the area. This method works because we're essentially tracking the limits of where ones appear. No matter how scattered the ones are, the rectangle formed by these boundaries will always be the smallest one that covers them all. The time complexity is m times n, where m is the number of rows and n is the number of columns, because we look at each cell exactly once. The space complexity is 1, since we only maintain 4 integer variables: top, bottom, left, and right. We don't need any extra storage proportional to the size of the grid. The key insight here is that not every grid problem needs complicated approaches like dynamic programming or multiple passes. Sometimes, simply keeping track of boundaries while traversing the grid is enough to solve the problem optimally. This technique of maintaining running minimums and maximums comes in handy not just here, but in many other grid and geometry-related problems too. It's a powerful reminder that simplicity often leads to the best solutions. And that wraps up our discussion on LeetCode 3195, find the minimum area to cover all ones. If this explanation helped you understand the problem and solution more clearly, don't forget to like the video and subscribe to BugNoJutsu. On this channel, we focus on breaking down problems step by step, making them approachable and easy to grasp. Thanks for watching, and I'll see you in the next video with another exciting problem breakdown.